Hi, this is the second part of the logistic regression video, and now we're going to talk about what happens when we increase the model size and include new features. So in the previous part we saw that the normal logistic regression model with normal features results in a pretty good model, but we did see some uncertainty here, and we are wondering, is there any way to fix that? So here in the range -4 to about 3 degrees, even the training examples are inconsistent and we have some overlappings. So we're wondering, is there anything that we can do better and solve that? So we are going to include new feature terms. So here we include the terms x squared and x to some power r. And that can be done by using the same polynomial features class that we used in the linear regression video. So here we are taking a degree and we're transforming our features so as they include this polynomial. So these features will be raised to some power. And then we fit the exact same logistic regression model. So here we can run this code for different degrees from 2 to 8. And as we can see, the 0,1 loss seems to stabilize after a degree of 5 at about 6% error. And the average logistic loss also seems to stabilize at about the same, at exactly the same degree. So here we're going to test to visualize what the models look like for degrees of 2, 4, and 6 and 7. So as you can see here, for a degree of 2, the model is very similar. It probably is almost the same as the simpler logistic regression model, but when we increase the degree, even though we have a pretty good loss of only 10%, so it's better than the previous one, but we see that there is this oscillation which we don't really like here. And then if we increase the degree even further, we see that these oscillations are much more prominent. So this is actually a sign of overfitting, because that means that our model has learned that, for example, when the minimum temperature is around -3.5, let's say, then the label is 1. So the model tries to fit that, and it doesn't really care about its neighbors, because, for example, if the minimum temperature is -4, then now the prediction is going to be almost certain that it is a high maximum temperature. There is going to be a high maximum temperature, but this is not really a good prediction, because the most of its neighbors of minimum temperature -4 are actually, as you can see here, low degrees. Yeah, so that is a sign of overfitting, and that's why we shouldn't really use this high number of degree, and instead here we will probably go with either the 2 or 3 degree, because it has a very good balance between the overfitting factor and the loss, which is pretty low.